Hi guys, my name is Jana Domenico. I'm a first year Chem PhD student and I work with Dr. Solberg in the theoretical physical chemistry lab. And right now I am running a bunch of calculations on superatom crystals. So that's a little bit about me. But I'm going to start my lesson today on something I tend to start with Gen Chem classes. It's just on the metric system. So hopefully everyone will follow. So I'm going to start with a little bit of a shortcut on how to think of the metric system, because especially if you're native to this country, you're probably a little confused by it, or you have been in the past. So we're going to think of it as a staircase. A 7-step staircase. This is what I call the metric staircase. So the middle of your staircase here is your base unit. So this is going to be your grams, your liters, your seconds, whatever is in this middle staircase. Excuse me. And all the other prefixes that we put in front of these units, they're going to be steps. So we start with kilo all the way at the top. We get kilometer, something like that. Hecto we don't really use. Deca we don't really use either. Deci not so much. The centi and milli are the ones we're familiar with on the bottom. So I'm going to just show you a quick example of how to use the staircase. So if we want to convert let's say 1 meter to centimeters, right? Now, if you're familiar with the metric system, you're going to say 100 off the top of your head, but I'll show you why using the staircase. So we're going to start by writing 1 meter, and there's an invisible decimal place behind that 1, right? So meters is going to fall under your base unit. It doesn't have a prefix in front of it. Meters here. So you want to go from meters to centimeters. So we're going to go down to this step here, right? Does that make sense to everybody? And we're going to do that by going down 2 steps to the right. So we're going to do the same thing with the decimal point. 2 places. So that would equal your 100 that we're all expecting to be there, right? So we know that that makes sense. Does everyone follow that? It's kind of cool, kind of a cheap way. But it's good when you're stuck and you can't remember your simple metric conversions, or you're saying, is that 1,000 in 1 or 1 in 1,000? If anyone's ever had that problem, you know what I'm talking about. So let's try another one. If we have 1,573 milliliters, and we need to do a problem that requires liters. Anyone have a guess what we're going to do? Where we're going to start? What step looks relevant here? And right down here? Okay. And where are we going? Of how many? 3, right? 1, 2, 3. Okay, so we're now in here. And we're doing the same thing with the decimal point. 1, 2, 3. Right. So this is going to be equivalent to 1.573 liters. Okay? Is that cool with everyone? So in chemistry, we exclusively use the metric system, which can kind of be confusing, but if you keep this in the back of your mind, it will definitely help. And I'll show you how to use it in what we call dimensional analysis, where we're just going to be changing the units. So I'll set it up. So this is how we tend to set things up. Instead of moving decimal points, we tend to set it up more like fractions. So if we think of 100, sorry, and 50. Then you're going to, this is going to be your starting number, and we're going to convert by placing a fraction next to it. And to cancel our units, we know that in every 1, that's 1 meter. She said move 3 steps to the left. Because we want, when we do fractions like this, we want everything in terms of 1. So we have 1 milliliter is 0.001 liters. Oops. Sorry. But, so this is how we're going to attempt to set things up. Did that confuse anybody? Okay. So then, in your calculator, you would just multiply these 2 numbers. So we could do the same thing without moving the decimal point, but expressing it more as a fraction, which is what you want to do on an exam or something like that. So if anyone wants to try, we have say a problem needs us to be in kilograms. So how would we move that? What would go in the top and the bottom of our fraction? Wake up, people! Anyone?
So we want kilograms on top and milligrams on the bottom.
Right. Good. So we cancel out. And what's the number in front? In front of each one.
Someone else?
Yeah.
1 kilogram.
1 kilogram on top. Is that okay? And then on the bottom, maybe somebody else. If anyone else feels brave today, please.
10 to the 6.
Okay. And how did you get that?
Like to the third, down
Right,
to
we're going
liters.
all the way down here, all the way up there. So we're going to shortcut and make it 10 to the 6. If anyone's confused about that, I'll explain that a little later. But then you would just put this into your calculator, and you have the simplified version. And your answer, whatever it happens to be, will be in kilograms, because these units will cancel, just like these units cancel.
So it doesn't matter if you put like 0.001 liters on the top or you use the whole unit on the top?
Doesn't matter. You'll get the same answer. Yeah. So, for example, that's a good question. The other way, you could write this up here. Okay. So you could write 1,000 on the bottom, and then 1 liter on the top. Right? And you'll get the same answer in your calculator. If you don't believe me, you can try it. Okay. Does that everyone have any questions? You want to try another one? I think everyone's got it. All right. Thank you. That's all I have.
All right, so any other questions or any comments in general on style presentation?
You're really confident.
Oh, thank you. I've taught this a lot of times.
One suggestion is just to try to make eye contact throughout the room. It seemed like for the
Okay.
most part it was this way. I mean,
Oh.
I know I'm the one who's like keeping a sheet, but you know, if you're ever giving a presentation and like your
Okay.
PI's in the room,
Yeah,
make
thank
sure
you.
you look at everyone else too.
Okay, thank you.
Okay. All right, thank you.